We've all heard stories about secret missions, missing files, and governments quietly steering the truth in whatever direction keeps the world calm. But every once in a while, something slips through the cracks, something so strange, so specific, and so inconvenient that the only real question becomes, who's trying to bury it, and why? That's the crossroads China's lunar program stumbled into. The deeper you go, the harder it becomes to shake the sense that someone found something they weren't supposed to. Something important enough that two rival superpowers, who rarely agree on anything, suddenly seem to share the exact same silence. Richard Hoagland began exactly where the establishment loves to place its smartest minds, inside the warm, structured world of NASA commentary and science communication. During the Apollo years, his job was to translate their victories for the public. He worked in science media, consulted for networks, and became one of those recognizable voices who explained space in ways everyday people could follow. And that's why what came next hit harder. Because at some point, Hoagland saw patterns he didn't like. The mission photos that didn't add up. The artifacts NASA released late. The lunar details no one bothered to explain. And Hoagland leaned into the role of the outsider who used to be an insider. That tension made him a problem for the establishment. NASA saw him as someone who had tasted authority and decided to rebel. But Hoagland saw himself as someone who refused to shut up when something didn't look right. Through the 80s, 90s and 2000s, he grew into a kind of underground figure. The guy who claimed there were artificial structures on Mars. The man who insisted certain lunar anomalies weren't geological mistakes, but signs of engineering. The researcher who argued that images released to the public weren't the raw originals, but safe versions scrubbed of inconvenient shapes and shadows. He was dismissed by many astronomers, mocked by some engineers, and flat out ignored by NASA. But he kept talking, and every time officials called him fringe, his supporters doubled. Still, for all the noise he created over the years, there was one thing Hoagland almost never touched head-on: China's space program. He would mention it, sure. Notes here, questions there, but he never went deep. He never made bold claims about China the way he did about NASA. He stayed away from that subject like it was a locked box he didn't want to open. Until now. Because after years of silence, he suddenly comes out saying China has discovered something on the moon and has been hiding it. He says it's the biggest discovery any lunar mission has ever encountered, and China has gone to extreme lengths to bury it. That shift alone was enough to shake people. Hoagland wasn't known for pulling punches, but he also wasn't known for focusing on China. So why now? What changed? According to Hoagland, he didn't speak earlier because he didn't have proof, not even partial proof. China's space agency keeps its files tight. Their mission logs are controlled, their image releases are inconsistent, and the scientists involved rarely speak freely. For a long time, Hoagland had suspicions, but nothing solid enough to risk. But recently, he claims he gained access to mission fragments from early Chang'e operations, telemetry breaks, tracking deviations, and short-lived internal data packets that shouldn't have leaked out but somehow did. And when he lined them up next to China's official timelines, the mismatch was too big to ignore. He says China found something at the lunar South Pole, something they didn't expect, something they couldn't explain. And instead of sharing it with the world, they buried it behind controlled press releases, delayed photo dumps, and vague technical jargon that says a lot without saying anything. Hoagland calls this discovery the point where silence becomes impossible. If Hoagland is right about that, then the next question matters even more. What exactly is China hiding? And why are their missions wrapped in layers of silence thicker than any space dust? China doesn't talk about its lunar program the way NASA does. There are no live-streamed launches with chat boxes exploding, no open archives of every attempted maneuver, no flood of high-resolution raw images uploaded for the public to explore. China treats the moon like a classified project, and that attitude didn't start recently. It's been part of their strategy since the very first Chang'e launch. To understand the scale of their silence, you have to look at their mission history. China has sent orbiters, landers, and rovers, each with official press releases that read smooth and polished. But beneath those clean updates are missing mission logs, unexplained communication blackouts, and long stretches where even amateur radio trackers couldn't pick up a signal from the spacecraft. One of the earliest examples came from Chang'e 2. The spacecraft went dark for several hours during a key phase, and instead of explaining the gap, China simply skipped ahead to the moment everything was back to normal. No technical rundown, no engineering report, nothing. And anyone who asked about it got the same vague answer: routine adjustments. Even NASA engineers quietly admitted that phrase means nothing. Then there were the images. China releases fewer lunar images than any other major space program, and when they do release them, the metadata is stripped out. The timestamps don't line up cleanly with the mission schedule. Some images show lighting conditions that conflict with published landing times. Others appear cropped, tight framing that makes it impossible to see what was beyond the rover's immediate view. This tight control isn't just unusual, it's consistent. Mission after mission, China behaves as though the moon is a territory they're mapping for internal use only. Chinese scientists often don't speak to foreign press. Their research papers sometimes appear months or years after the mission ends. Even the names of onboard instruments are occasionally withheld until long after launch. And that secrecy raises a question. Why hide so much from a place that's supposed to be empty? Hoagland argues that the pattern becomes clearer once you compare it to older NASA behavior. During the Apollo era, the US also held back certain photos, delayed others, and lost entire reels of telemetry. The official explanation was always resource management. But Hoagland claims China is repeating the same habits for the same reason, because they found something unexpected. You can see the secrecy peak around the far side missions. Chang'e 4, China's biggest achievement, landed on the far side of the moon, where radio signals don't naturally reach Earth. To communicate, China used a relay satellite beyond the moon. But during that mission, there were unexplained bursts of interference. The relay went silent for short intervals, then returned as if nothing happened. China never commented on the blackouts. They simply removed those timestamps from the timeline. And then there's the missing footage. China promised full landing videos from several missions, yet only released heavily compressed short clips. Not one uninterrupted sequence, not one raw feed. Rovers that should have captured long panoramic sweeps instead shared tightly controlled frames that feel more curated than scientific. Even China's top scientists seem unusually cautious when discussing the moon. They talk openly about Mars, asteroids, deep space exploration. But the moon, they become formal, careful, choosing words that say less than they mean. Hoagland believes there isn't personality or culture, it's coordination. But here's where things really turn. The missions with missing logs overlap with the locations Hoagland has focused on for years: the southern polar region and the far side. These are the areas long rumoured to hold unusual formations, strange thermal readings, and shadow anomalies no one has fully explained. And China has been landing exactly there. Hoagland says that's no coincidence. He believes China went to those regions because they knew the rumours. And what they found forced them into the same quiet posture NASA once took. Whether he's right or not, the secrecy is undeniable. China's lunar missions have more blank spots, missing minutes and silent stretches than any modern space program. And every time a new mission begins, that pattern repeats. The moment Hoagland brought up the lost telemetry files, the entire conversation shifted. He was talking about raw mission data, streams of numbers that reveal a spacecraft's true path and behavior. And according to him, the fragments he received didn't match China's official story at all. Hoagland says the data came from a small group of hobbyist trackers. These were radio enthusiasts, the type who build antennas in their backyards and spend their nights scanning deep space frequencies. Most people don't realize it, but civilian trackers often catch pieces of real telemetry long before agencies release anything. They listen for the carrier tone, decode what little they can, and compare it with the mission's public timeline. Usually it matches up well, but not this time. The group contacted Hoagland because something in the Chang'e mission timeline wasn't lining up. The spacecraft wasn't where China said it was supposed to be at the exact moment they announced it. The trackers didn't have full data, just short bursts of encoded telemetry that slipped through because China didn't shift frequencies quickly enough. Hoagland says those bursts told a different story. The spacecraft drifted off its published track, then corrected itself, then drifted again. When Hoagland laid out the fragments, a pattern formed. There were gaps at moments when you'd expect constant data. Missing altitude readings, missing lateral velocity, missing thermal reports. China's official report claimed everything was nominal during those exact windows. But the telemetry fragments showed the opposite. The spacecraft was adjusting when it shouldn't have needed to. He also pointed out that the shape of the gaps looked familiar. Back during the Apollo missions, NASA lost entire blocks of telemetry. Days of data from Apollo 11 vanished from the archives. Whole reels went missing. NASA blamed storage errors and archiving mistakes. Critics never believed that, and Hoagland definitely didn't. So when he saw similar gaps in China's mission logs, gaps that matched the same pattern of timing, the same pattern of sudden silence, it felt like history repeating itself. What stood out most was how the telemetry fragments didn't just vanish randomly. They disappeared at critical phases, mid-course corrections, lunar approach, orbital adjustments. If the spacecraft had malfunctioned, China would have addressed it. They usually downplay problems, but they don't pretend everything was perfect. Instead, the silence came exactly when the spacecraft was passing over a region Hoagland has always claimed was sensitive: the Southern Pole. Hoagland argues the spacecraft saw something it wasn't ready for, something that forced a change in trajectory, something China didn't want the world to know. And if the telemetry drift wasn't strange enough, the timestamps added another twist. China's published mission timeline didn't sync with the fragments. Events that China claimed happened at one moment appeared in the data several minutes earlier or later. You don't get those mismatches unless someone is rewriting the mission log after the fact. Hoagland believes this wasn't sloppy editing. He says the spacecraft took a detour. China scrubbed the timeline to hide that detour, and the missing telemetry is the footprint of that cover-up. The idea starts sounding less theoretical when you compare the missing sections to the Rover landing site photos China eventually released. The lighting angles don't match the landing time they announced. The shadows look like the sun was at a different altitude. And the ground temperature looks wrong for the local lunar morning they claimed. And if the telemetry hints at a detour, the next clue gets even louder, because when China's lander actually reached the South Pole, nothing about its final descent matched the plan they'd been boasting about for years. The South Pole of the Moon is no ordinary landing site. It's a place filled with deep permanent shadows, ancient craters and ice pockets that have survived for billions of years. Every space agency wants a piece of it, China especially. They've been aiming for that region since the earliest Chang'e missions. Their public plan was simple: target a safe, open zone with predictable terrain. But the spacecraft didn't land where it was supposed to. It drifted enough to raise questions. When the final coordinates were confirmed, independent analysts noticed something strange. The lander touched down several kilometers off the intended track. Not because of wind, there's none on the moon. Not because of navigation error, China's guidance systems are too refined for that. Something changed mid-flight. Hoagland thinks that something wasn't technical. He says China changed the landing targets on purpose after the spacecraft spotted an anomaly on the surface. And here's where the temperature issue comes in. China released thermal maps of the landing zone, but the numbers didn't match what scientists expected. The ground appeared warmer in some shaded areas than it should have been. Shadows at that angle shouldn't allow heat to build up. But there it was, pockets of warmth where there should have been nothing but freezing silence. Hoagland interprets these warm patches as a clue. Natural terrain doesn't heat unevenly like that on the moon. It requires something beneath the surface. A structure, a cavity, or a buried object with thermal properties different from rock. Then there were the shadow inconsistencies. When China released the first landing photos, researchers quickly noticed the shadows falling in directions that didn't match the stated landing time. The angle of the sun appeared too low, the shadows stretched too far, and the rocks in the frame reflected light in ways that felt off, almost like the photographer wasn't standing in the lighting conditions China claimed. Hoagland seized on one photo in particular. A stone in the corner reflected a clean, sharp glint. Lunar dust doesn't usually reflect light like that. It's matte, chalky, scatter-heavy. Something smooth was in that frame. Something with a surface that caught sunlight like metal. China didn't comment on any of this. They simply released the images, published a short scientific note, and moved on. But Hoagland didn't. He zeroed in on those lighting discrepancies and argued that China edited the images to hide what the lander was actually looking at. He believes the lander changed course because its onboard cameras spotted shapes on the ground, shapes that weren't natural. The thermal anomalies back that up. The shadow inconsistencies confirm it. And the detour proves China saw something and made a decision: avoid the direct landing zone and drop somewhere quieter. One more detail seals his concern. Lunar landers always perform small hover and adjust maneuvers before touching down. But China's lander hovered longer than usual, much longer. That pause is logged in their public data. But what China doesn't explain is why landers don't hover without a reason. Fuel is precious. Hovering wastes it quickly. Is only done when the onboard system sees something it doesn't like. Whether that something was artificial, geometric, or simply unknown, Hoagland doesn't jump ahead here. He just points to the evidence: thermal hotspots, reflective surfaces, long shadows, delayed timestamps, and a landing detour that doesn't make sense unless the mission saw more than it was supposed to. The first thing he focused on wasn't the rover at all. It was the ground behind it. Lunar dust settles in predictable ways. It clings to surfaces, piles up around wheels, and forms soft crescents whenever anything pushes through it. But in the rover's earliest tracks, something didn't look right. The dust had been dragged sideways, not forward. This only happens when the rover jerks to dodge something. The track pattern showed a sudden shift in direction. A clean, sharp deviation. Rovers don't make moves like that unless they're avoiding obstacles directly in front of them. Yet every photo released by China shows nothing in that direction, except open terrain. Hoagland says that's the first sign something was edited out. Then he turned his attention to the way the dust reflected light. Lunar dust usually absorbs more than it reflects. That's why Apollo photos show such flat, muted brightness. But in some rover shots, the dust looks brighter than expected, as if light bounced off something reflective nearby. Hoagland describes this as secondary reflection, the kind you get when sunlight hits a smooth surface and scatters back onto the ground. There's nothing on the moon's surface with that kind of finish. No natural minerals there behave like polished metal. Yet those reflections are there, showing up faintly on rover panels, dust ridges, and parts of the terrain the camera barely caught. The strangest part, though, was the shadows. In every lunar mission, shadow lengths reveal distance and height. They give away the size of objects, even when the objects themselves are off frame. Hoagland noticed a thin shadow stretching across the dust behind the rover. It was narrow, straight, and far too long to belong to a small rock, and the angle didn't match the rover's mast or its antenna. Something tall cast that shadow. But the object itself? It wasn't in any of the photos, only the shadow remained. Hoagland became convinced the Chinese space agency edited out whatever was standing on the horizon during those early scans. He believes they cropped the images aggressively, blurred edges, and patched areas with duplicated dust textures. The repeated patterns in the background give it away. The same rock appears twice in different spots. Dust mounds seem cloned, and one section of the horizon has a perfectly straight line, which shouldn't exist in natural lunar topography. If China edited out structures from the rover photos, the question becomes simple. What kind of discovery would force them to hide it? When China launches a mission to the moon, they always publish a clean diagram showing each component. A lander here, a rover there, maybe a small deployable instrument on the side. It's neat, simple, and perfectly arranged for public consumption. But those diagrams aren't the whole story. He argues that China often includes undeclared modules inside their spacecraft, compartments without public descriptions, boxes without labels, payloads that don't appear on any official list. Hoagland claims China's early missions, specifically the ones aiming toward the South Pole, carried equipment designed to scan beneath the moon's crust. These instruments can map density, detect cavities, and reveal metallic signatures deep under the regolith. He believes China built them after studying old Soviet research, which hinted at strange internal reflections beneath certain lunar regions. And the secret payloads were the key to the entire mission. He points to the unusually large lower compartment of the Chang'e lander as proof. Public documents show a simple storage box, but comparative measurements don't match. When you analyse the mass of the lander, the numbers don't line up with the visible components. It weighs more than its declared instruments. That extra mass has to come from somewhere. Hoagland argues that China hid a ground-penetrating radar array capable of scanning kilometres beneath the surface. They used the lander not just to explore, but to investigate something specific in the South Polar region, something they'd identified long before launch. This is where the missing telemetry makes sense to him. He says China activated the hidden scanner during descent, and the results forced them to change landing coordinates. The subsurface readings may have revealed a hollow area, a metallic formation, or a dense structure buried deeper than expected. Whatever it was, Hoagland believes it confirmed an old theory. The moon's south pole might hold artificial remnants. Tibi also points out that China's Rover, U-22, carried a radar instrument much more powerful than anything NASA has ever put on the lunar surface. Officially, it was designed to study layers of regolith, but Hoagland says its capabilities go far beyond that. The rover could detect vertical structures, metallic columns, hollow chambers, and unnatural density shifts. He thinks China didn't advertise these abilities because they weren't looking for geological information, they were searching for hidden architecture. If that sounds strange, compare it to Earth. Archaeologists use ground-penetrating radar to uncover buried, ancient structures. China applied the same idea on the moon. His argument gets stronger when you look at China's secrecy around data release. Normally, scientific agencies proudly share new findings, but China published only a fraction of their radar data: tiny slices, cropped sections, low-resolution samples. The key detail for Hoagland is the size of the undeclared modules. They're too big to be batteries, too big to be flotation systems, and too big to be empty storage. They match the size of industrial radar units, the kind used for military-grade scanning. He believes these secret devices were built specifically to target the South Pole, because China already suspected something was buried there. There's a thread running through this whole story that ties modern radar scans, old Soviet speculation, and unexplained radio bursts into one disturbing possibility. The moon might be more engineered than geological. The hollow moon idea didn't begin as fringe speculation. It started with observations, measurements, and a few oddities that didn't fit simple rock and dust explanations. During the 1950s and 1960s, as radar and seismology developed quickly, some Soviet and Western researchers noticed anomalies in how the moon rang and reflected signals. Lunar seismic readings sometimes produced reverberations that lasted longer than expected after meteor impacts. Radar echoes occasionally returned stronger, or with a character that didn't match known regolith properties. Those early papers and notes quietly recorded behaviour that seemed odd under purely geological assumptions. Scientists proposed several explanations. One was straightforward. The moon's interior might have layered structures, pockets of different density that cause unusual echoes. Another suggested large, deep cavities could change seismograph responses. A more radical suggestion argued for reinforcement, regions of the moon containing materials or formations that act like metal or engineered shells. Most mainstream geologists preferred the conservative views. They emphasized impact fracturing, basalt flows, and uneven mineral distributions. Those models can explain many anomalies, but some patterns remained stubborn. Hoagland approached the theory differently. He refused to accept the label of wild speculation, but he also didn't treat the evidence as settled science. Instead, he treated those early anomalies as clues pointing to layered complexity. Where traditional scientists saw measurement error or complex geology, Hoagland saw potential design indicators, consistent reflective signatures in specific regions, repeated patterns in shadow behaviour, and clusters of thermal anomalies near certain craters. He mapped those oddities together rather than isolating them, looking for geographic coherence across datasets. Shackleton sits near the lunar South Pole. Its rim sees sunlight at low angles, and its interior captures long-standing shadows that keep temperatures extremely low. For decades, Shackleton has been a target for water ice detection and thermal studies, but it also shows unusual radar reflections and shadow behaviour that caught Hoagland's attention. Radar echoes from the area have returned stronger, or with phase persistence that's harder to explain by loose rock alone, and thermal maps show localized warmth that doesn't fit simple solar heating. When those signs cluster at one location, they become a pattern worth investigating. Hoagland argues there are 3 measurable signs that suggest reinforcement or structure rather than natural geology. First, coherent radar echoes that maintain phase over longer times indicate reflective, possibly smooth boundaries beneath the surface. Second, seismic reverberations with consistent decay patterns suggest enclosed cavities rather than diffuse, dissipative layers. Third, localized thermal retention in shadowed pockets points to materials with higher thermal inertia than surrounding regolith, which would hold heat differently across diurnal cycles. The compelling angle is timing. The Soviet-era anomalies were small and hard to follow because instruments lacked resolution. Modern instruments, especially those China deployed, sharply improved depth and clarity. Ground-penetrating radar now resolves layered signals at resolutions previously unavailable. Hoagland's position is that China's secret payloads and the leaked telemetry samples map onto those same Shackleton signals, but with far better resolution, making the older hints look less ambiguous. Hoagland is careful about wording. He doesn't claim the moon is a machine. He frames the argument as a structural anomaly, something that behaves like reinforcement. The anomaly near Shackleton could be a cavernous space with reflective surfaces, possibly arranged in ways that repeat geometric relationships. That repetition is what separates a geological oddity from a constructed form. Natural processes rarely create repeated geometric spacing over large scales. When they appear repeatedly and match across electromagnetic, seismic, and thermal datasets, the possibility of non-random structure rises. If China's subsurface scans did reveal consistent, repeating internal reflections beneath Shackleton, the implications would be enormous. It would mean the moon's interior might host formations that are functionally similar to engineered cavities. Such features could be natural but altered, or they might result from processes not yet understood. For Hoagland, the immediate consequence was pragmatic. A discovery like that shifts behavior. You don't publicly broadcast raw scans from an unknown reflective cavity before you understand how it interacts with instruments, or whether the feature could be hazardous to approaching hardware. Hoagland notes one more modern twist. The idea of a hollow or reinforced moon aligns with some unexplained historical notes in mission archives. Certain Apollo-era photos and early radar logs showed odd reflections and shadows near craters that were downplayed in official reports. Hoagland argues those earlier hints, and China's recent radar returns, point to the same phenomenon: local regions that respond to signals like surfaces rather than loose rock. Each new dataset layers on previous ones and strengthens the argument for targeted investigation. But counter-arguments exist. Geologists point to impact melting, stratified basalt flows, and metal-rich deposits as plausible causes. Advanced modelling can reproduce some radar and thermal anomalies without invoking reinforcement. While models can match individual data points, they don't align with the full set of signatures that include coherent harmonic responses, consistent seismic decay patterns, and synchronized thermal anomalies. But there is another clue: repeated radio bursts on the far side that some dismissed as noise. Hoagland sees those bursts as the most direct sign that whatever is beneath the surface is interacting with electromagnetic signals in structured ways. The far side of the moon faces away from Earth and holds a distinct radio environment. It's shielded from terrestrial noise, which makes it ideal for radio astronomy. That same isolation also reveals anomalous transmissions that would be drowned out near Earth. China's relay missions opened a listening window into the far side and recorded bursts of radio energy with repeating structure rather than random noise. China publicly labelled several of those events as interference, cosmic background, solar flares, or equipment artifacts. Hoagland disagrees. He analysed frequency logs that leaked and compared them to known interference patterns. What he found looks geometric. The bursts occur at intervals, and frequencies that, when plotted, form ratios consistent with simple harmonic relationships. That pattern doesn't match the broad, chaotic spectra, typical of solar noise or distant cosmic sources. The distinction matters because natural processes tend to produce wideband or noise-like frequency distributions. Artificial systems, especially resonant cavities or engineered reflectors, produce narrowband harmonics and repeating echoes. Location strengthens the case. The bursts were strongest when the relay sat over the far side region, aligned with Shackleton's anomaly. Spatial correlation matters. If structured bursts appear only when receivers are positioned over the same area, where radar indicates layered reflections, correlation moves toward causation. Another key detail is pulse shape. The burst showed abrupt rise times and sustained decay tails, signatures consistent with resonant ringing rather than transient chaotic emission. The recorded tails contained sidebands that align with echoes inside bounded volumes. Where a typical cosmic burst fades irregularly, these signals demonstrate clean decay patterns and repeated side frequencies that suggest internal reflections. Beyond the technical details, the politics matter. If multiple independent observers confirm the bursts and their spatial link to Shackleton, the discovery shifts from scientific curiosity to geopolitical asset. Control of a region that reacts to electromagnetic probing would be strategically valuable. Hoagland points to the speed of China's internal lockdown as evidence they understood that implication early. To understand why China would bury evidence, Hoagland says you have to look past the obvious goals, mining, exploration, national pride, and consider the deeper strategic motivations. For China, the moon is a symbol, a resource, a military platform, and a geopolitical equalizer. Revealing anything that shifts global power balance is a risk Beijing won't take lightly. China's lunar ambitions operate at multiple levels. At the surface, they want to secure helium-3 deposits, map ice pockets, and establish long-term technological independence. These goals look standard, even admirable, but beneath that surface sits something more strategic. Whoever controls the moon controls future space logistics, off-planet manufacturing, and deep space infrastructure. That's where national power shifts from Earth to orbit. Hoagland argues that China's silence is part of a larger strategy. If China discovered something artificial, something that predates all human civilization, it would instantly shatter every nation's script for how space politics works. Whoever reveals such a discovery loses control of the narrative. Because the moment the world knows there's something engineered on the moon, every nation demands access, verification, and a seat at the table. China would lose exclusivity. The US would lose secrecy. Russia would demand cooperation. Europe would call for transparency. Instead of gaining influence, the first nation to reveal the discovery becomes a global focal point, forced to answer for the entire planet. China wants none of that. They prefer a quiet moon, a controllable moon, a moon where narratives move slowly and carefully. If something artificial exists, China would want years of private study before acknowledging anything publicly. Strategically, silence gives them options. They can study the structures, test materials, scan deeper layers, and explore without foreign oversight. They can establish data pipelines and analyze resonance effects without the world tracking every probe. They can map internal cavities, test radiation levels, and look for patterns or repeating geometry. And because they control access to their raw data, they choose which details leave the room. Hoagland also points to China's political culture. The government prefers controlled messaging. Scientific teams rarely speak freely without authorization. Sensitive findings move through layers of approval before going public. When missions involve potential discoveries that challenge Earth's understanding of history, the approval chain becomes even tighter. That's why China sometimes delays entire mission datasets for months or releases partial images without comment. He believes the US mirrors this behavior for different reasons. The US fears destabilizing scientific consensus, complicating alliances, and igniting global debate over the origins of such structures. If the moon contains artificial forms, questions about creators, timelines, intentions, and implications become unavoidable. Those questions bleed into religion, philosophy, geopolitics, and military planning. The ripple effect could transform everything from education to funding allocations. Both nations protect the same long-term interests: stability on Earth. Announcing that structures exist on the moon risks unpredictable consequences, economic shocks, ideological conflicts, or races to control lunar sites. It could spark military tensions as nations scramble to secure landing zones near anomalous regions. Silence prevents that. But Hoagland adds one more reason China wants quiet: possession. If artificial structures exist, China wants ownership of the first interpretation. They want to study the materials, understand the design, and analyze any patterns without sharing credit or influence. They want to be the first to decode resonance signals, map internal reflections, or identify technological signatures. That leads to the uncomfortable conclusion Hoagland keeps circling back to. China isn't hiding ignorance, they're hiding confidence. They found something they believe is real, significant, and strategically valuable, and they're not ready for the world to know.